right, well, it is 10:04, so I'm going to go ahead and get started. Good morning, everyone. Welcome to the July monthly partnership meeting of the Southeast and Caribbean Disaster Resilience Partnership, or SCDRP. My name is Claire McGrath. I have the honor of serving as the director of SCDRP as of July 1st, following in the footsteps of Heather McCarthy. I started with SCDRP in May of 2024, and I'm excited to continue the initiatives that Heather started and partner with all of you for a more resilient Southeast and Caribbean. So if you want to get to know me, feel free to drop me an email, claire@socorro.org. I also put my email into the chat. A warm welcome to all of you, and thank you for joining us. So our agenda for today, I'm going to start out with a couple of SCDRP announcements. Then I will introduce today's speaker, Adrian Santiago Tate, CEO and co-founder of HighTide Intelligence. Then we will wrap up today's meeting, as always, with partner sharing. Okay, our first announcement for today, it is an absolute honor to welcome Alexander Easdale to the SCDRP Advisory Board. Alex will be serving on the board in the nonprofit seat. Alexander Easdale serves as the founding executive director of the Southeast Climate and Energy Network, SEN, where he leads and manages a network of about 75 environmental and climate organizations across 11 southeastern states. Since 2016, he has supported SEN's mission to confront the climate crisis by creating strategic alignment, growing capacity, and building power among member organizations and their communities in the southeastern United States. He's also the managing principal of the social enterprise consulting firm Forging Alliances. We are very grateful to Alex for bringing his rich experience and skill set to the SCDRP Advisory Board. Next up, the last session in our summer group mentoring workshop series, Pathways to Resilience, is next Thursday, July 31st from 4 to 5 p.m. Our presenter for this session is Megan Jones, an advisory board member, and the Coastal Resilience Specialist from University of Georgia and Marine Extension and Georgia Sea Grant. This series is aimed at supporting students and early career professionals, but it can be beneficial to anyone who wants to learn from another professional in the field and build their network. Megan will share insights into her role as Coastal Resilience Specialist, recommendations for others who are seeking to advance their careers, and answer your questions about the field. Next up, we are very excited to announce that cohort number 2 of the SCDRP mentorship program will be a collaboration between SCDRP and RCE Greater Atlanta. RCE Greater Atlanta brings together universities and colleges from across the Greater Atlanta region with nonprofit, community, government, and business partners. RCE Greater Atlanta was acknowledged by the United Nations University in 2017 as a regional center of expertise on education for sustainable development. So RCE support implementation of the UN Sustainable Development Goals at the regional level through education and training. We're really excited about this partnership. With this partnership, the program will continue to serve professionals across the Southeast and Caribbean region, not just the Atlanta area. And it will be structured similarly to last year, where we will match students, early and mid-career professionals with seasoned, resilient professionals for monthly one-on-one mentorship sessions. So with our partnership with RCE Greater Atlanta, we're excited that we'll be able to offer additional workshops and opportunities for engagements as part of the program. We will be releasing our interest survey next week over email and social media, so keep an eye out for more information. Next up, save the date. For March 4th to 5th, we have our dates. March 4th to 5th, 2026, for the SCDRP 10th Anniversary Annual Meeting in Charleston, South Carolina. We are very grateful to the College of Charleston for hosting this milestone event. 10 years, big deal. If you have never been to an SCDRP annual meeting, head on over to our website using that QR code to explore past annual meeting reports, hear some testimonials, and learn what makes our meeting so special. Registration for the annual meeting will open in the fall, so stay engaged with our newsletter and our LinkedIn for some important updates. And next up, it is a pleasure to introduce today's speaker, Adrian Santiago Tate. Adrian is the CEO and co-founder of HighTide Intelligence, a flood risk data company on a mission to accelerate flood adaptation with data-driven technology. He led the development of the peer-reviewed Stanford Urban Risk Framework, which underpins HighTide's economic and social impact modeling. Adrian built HighTide through vulnerability assessments with communities across Florida, automating the process to accelerate local planning. HighTide was later contracted by the Puerto Rico Science Trust to launch its public platform, Arcly, in Puerto Rico. In Florida, Arcly makes flood risk data freely available to residents and offers a one-stop shop for comparing the cost of flooding to the cost of solutions. HighTide is now working to bring these tools to communities across the Caribbean. Adrian also serves on the board of the Flood Mitigation Industry Association. I think I can speak on behalf of the partnership in saying that this question of how AI and machine learning has the potential to transform the field of climate resilience in the coming years is on everyone's mind. So, Adrian, we are really excited to learn about your experience using data-driven technology for flood adaptation and to ask you all of our burning questions about AI and resilience. Thank you so much for taking the time to join us today, and a very warm welcome to you.
Thank you so much, Claire. I hope I can answer your questions. So let's see. I'm ready to screen share. Oh, there we go.
All right. Yep, you are now the presenter.
Okay. Can everyone see my screen?
Looks good.
Okay. Amazing. Well, thank you so much for having me here today, Claire, and everyone for joining and taking the time. Also, shout out to the people that invited me to get on and present today. It's my first time engaging with the SCDRP community, so I'm very excited to meet more of you. So like Claire said, the burning question is how is AI going to impact my job? I know it's on a lot of people's minds these days. And today I'll give you the perspective from a small team we've automated flood risk analysis for all of Florida. We've built scalable solutions. So what is it like on the inside? And what's going through our minds? But first, I wanted to share a little bit of my personal story. So all of this started for me when I was 8 years old, running around inside storm surge barriers in the Netherlands. Um, my family moved there when I was 8. My dad was an engineer. So what made sense to him, more than going to see tulips and windmills, was to go see some infrastructure. So that was my first impression. That's what got me into coastal engineering and coastal management in the first place. And years later, I found myself at Stanford working on a PhD looking at how nature-based solutions could mitigate flood damage. And along the way, I got involved in this project that was really exciting. There's a photo of me and Arnav winning the hackathon. And it was so exciting that I joined the club of people that drop out of Stanford to start a company. And I drove across the US in my Subaru with 300,000 miles, put a trailer hitch on it. It died when I got to Florida. And that's how I started HighTide. So now back to the methodology that got us excited. We called it the Stanford Urban Risk Framework. And the goal of developing this was to go beyond the traditional economic impact analysis and look at, okay, there's people being impacted by flooding. What is their income? How does that impact their ability to continue living in this place, or will they be displaced? So we wanted to answer that question, and to do so, we had to develop this methodology that goes beyond what tools like HAZAs typically allow you to do. And just to paint you a picture, we had 3 dozen students, graduate students, where each one of them had a specific task they had to do. So there was one person that would do something in Excel, hand it off to the next person who would do something in GIS, back to Excel, little Python script, very disjointed process where if any of the data changed at the beginning, you had to start over and do all the handoffs again. And if you wanted to improve it, it was a mess. So I kind of took it upon myself to write Python code for this entire process from start to finish. And this is kind of what snowballed into this entire project. We ended up publishing this methodology. We got awards from Stanford and Microsoft, and then years later got awards from the East Central Florida Regional Planning Council that I have to give them a shout out. I know Tara is here. Um, so anyway, just the SURF methodology is what got us really excited because it allowed us to say, hey, this is where people are most likely to be displaced, and we can put a dollar value on flood risk for all these different buildings. And this matters because flooding is the most expensive disaster. So if people can understand what their flood risk means in dollars, which usually it's a big number, then they can compare that to the cost of solutions and make better decisions about how they're going to manage their flood risk. So we thought this was a compelling foundation to build a company where the entire mission is to accelerate flood adaptation. So we went ahead and we optimized and automated this process for so that we could go to scale, so that we could push a button and quantify flood risk for every single building in the state of Florida. And the original code that we wrote in the academic days worked, but it wasn't fast enough. So we could maybe run it for a county, but not for the entire state. So there were parts of the code that we had to optimize by 100x, and there were even some bits that we had to optimize by 10,000x, just so it would run fast enough. And then we had to automate it so that, like I mentioned before, go from 3 dozen students having to do their individual bit to having just a single button you can push and run the entire analysis. And then when the data gets updated, push the button again. So this was, for us, this was very exciting. We got to this milestone of being able to do this. But what we learned from working with planners, floodplain managers, emergency managers, resilience people in general, is that everyone's a little busy working on these vulnerability assessments, these VAs in Florida. So we thought we had this very exciting data set, but everyone tells us, yes, it's an interesting data set, but we're a little busy with these VAs. So we decided we had to automate that too. So we did. So today, what I'm going to talk about is 2 case studies. One is looking at SURF and the different data sets that go into flood risk analysis and how AI can be helpful with those data sets. And then I'll talk about, what do these projects actually look like, these vulnerability assessments? What are the parts that we can automate and what are the parts we don't want to automate? Going back to SURF, a little overview of flood risk analysis. There's 3 main data sets that you need. You need your hazard data, so your flood models. You need your exposure data, which is, hey, what is it that's getting damaged, right? What's exposed? And then you need to know about your vulnerability, like how much flooding does it take to get how much damage? So let's start with the hazard data set. This is typically how every flood risk analysis project starts. You need to run a flood model. So traditionally, that has involved engineers who have a lot of background in this, running physics-based models, and it's a rather, costly in terms of time, in terms of computational resources that are needed, and also takes a lot of expertise. So I wanted to share a couple examples or a couple applications of AI that I think are exciting in this space. So the first, which I think to me this is the really crazy one, is a team out of MIT that trained a flood model, that trained an AI model on the actual physics of fluid dynamics. So it basically serves as a shortcut for the computation of, inverting the matrices and all these things that you do with numerical models. It basically serves as a shortcut for that. It still looks like a physics-based model, but it runs hundreds of times faster. So they're able to run what you would typically run on a supercomputer on their laptop. So that's, to me, that is very exciting because it gets you scale, it brings down the computational cost, it brings down the time, allows you to go further and quantify uncertainty by doing Monte Carlo simulations, doing more simulations. So this is a pretty exciting application in my opinion. And then the second one is a company called Hohonu that does flood sensors. A few years ago, they shared this with me. They had, once they placed one of their flood sensors in a location, they're looking at all that data they're collecting to come up with better predictions of what the water level is going to be. So you can see on the screen, the thick purple is the observation, the light purple is their prediction, and the light blue is NOAA's prediction. And NOAA's prediction is only based on astronomical forcing. So by having this local flood sensor data inform a machine learning model that then makes these predictions, they're able to do a better job than NOAA with their own prediction. So these are some cool applications in the hazard space. On the exposure side of things, anyone that has done an analysis like this knows that this is the really tedious part. You've got to spend a lot of time making sure that your data is in the correct location, that it represents the correct thing. If you're looking at buildings, traditionally before you had some of these automation tools, people were manually drawing these polygons on the map, and there's millions of buildings out there. If you wanted to extract first floor elevation data, which is very important for flood risk analysis, then you're either manually looking up elevation certificates or you're going on Google Street and trying to guess the height, very burdensome. And this is an area where AI really shines. It's very good at extracting data from things like images. So a great first example is a project that Microsoft did and put out years ago, where they're using a machine learning model to extract building polygons from satellite imagery. We use a lot of this data. We also enhance it with data that has been manually curated to make sure we don't miss anything. But this is a great example. And then another good example is there's just so many companies that are doing this, primarily serving the insurance industry, that are using drone imagery or satellite imagery or oblique aerial imagery or even street imagery to extract building attributes. So, for example, roof pitch, number of windows, number of stories, first floor height. These are all data attributes, property level data that companies are going out and collecting using machine learning and tools like this. Um, so something um, that is very easy for us to do now is to extract elevation data from elevation certificates, which are these documents that I'm sure many of you are aware of that contain survey level elevation data. So that these kinds of tools really help us to not only populate very quickly large exposure data sets, but also enrich them with useful information. And then finally, I have to mention vulnerability. So typically, what most of us are doing is using depth damage functions from the Army Corps of Engineers. These are empirically derived from past events. And I don't see many people doing this, or almost anybody. But if you have access to a large data set that gives you more information than just depth and damage, maybe more information about the building itself and different other variables, you could then train a model to come up with much more accurate vulnerability functions for different building types. But again, I don't really see this happening very much. So it's definitely exciting, but there are limitations. So we have to keep those in mind. And the most important thing to keep in mind with not just AI, but any model is that it's only as good as the information that you feed it. So if there are any gaps in your training data, then there will be gaps in the output. And if there's bias in your training data, then there's going to be bias in the output. There was a very interesting article that came out, a research article by Apple recently, that showed that the AI tools that we're working with, the large language models, they appear to be very good at guessing, but they are actually very poor at understanding and reasoning. So it's good to keep that in mind. It looks very smart, but really it's just a very good guesser. Okay, so on to the second case study. This is, to me, the really interesting one, is how does automation and also enhanced by AI, how does that help us with these vulnerability assessment projects, as an example? and how will that impact the role that people play in these projects? So, to paint you another picture, for those of you that are not familiar with VAs, typically what happens is the first step is that you want to get all of your data, right? So all the stuff I was talking about with surf, your hazard data, your exposure data, you need to go and collect that. The flood modeling is a beast of its own, and then there's the asset data. So normally we're getting the data from the state. It's a large data set. It's a mashing of many different large data sets all in one place, and it's pretty messy. And you really want to have someone look at this data and make sure that everything is in the correct location and represents the correct thing. And that takes a lot of time. So once you've done that, gone through that process, then you can actually run through your analysis. And then you can create your report with your maps and your tables. And that involves a tremendous amount of manual work, a lot of manual formatting. So Rhonda, this client that I made up, she spent so much time manually formatting all of these appendices with hundreds of pages of tables and maps because she wanted it to look perfect. And then and then the typical thing that I see happen in almost all of these projects is that the project is almost finished. You're like a week from your deadline, you're about to deliver it, you think everything's fine, and then your client says, "Oh wait, I've got 20 more assets for you to add to this data set. We just looked at it." They had months at the beginning of the project to do it, but they looked at it the last minute and now they want you to add these assets. And that means that you have to go back and redo the analysis, make any changes to the report, and update all of these maps and tables manually. So this is something that several of our clients were just banging their head against the wall. They wanted to go cry in a corner and then spend the next 3 weeks having to deal with these updates. So we decided, okay, this place where there's this huge pain point and people really hate doing this is what we need to automate. So by going through the different parts of these projects and figuring out all the parts that people didn't like doing, we were able to automate pretty much 80% of the manual work that goes into doing a vulnerability assessment. And the point that I want to make now is that we did all of this without using any AI. This was just traditional software automation, right? So AI adds this additional layer of automation, and what does that look like? How does AI actually help us take things further than just regular automation? And I wanted to share this analogy that to me is very helpful for understanding kind of the role of AI, at least as we see it so far, because it's changing so quickly. But you can think of AI as being like the automation of labor. It's the same to labor as what engines were to mobility, right? So before the internal combustion engine was invented, people are riding around on their horses and carriages. And the engine comes into play, and now you can go farther, you can go faster, and you don't have to take care of a horse, right? A lot more convenient. So it's kind of a similar situation with AI. It's going to automate a lot of tasks. It's going to make life easier. And we think of it in our company as almost like this layer that's all across. I mean, pretty much every task you can do, there's some way that it could be automated or could be made easier with AI. But then, of course, there are places where it can't be automated. So here's a great example. Report writing is a great example. We've had a lot of people reach out and say, "Hey, can we automate writing these reports?" So there were a few report products that we've developed where at the push of a button, we can generate a report for any community on the coast in Florida because we have all this data already. We've already checked the data. We feel good about it. So we feel comfortable writing a report that we automate. And the part that and we've done this without AI. And the place where we think, okay, AI could fit here is what we call the flavor text, right? So you've got this report and the process shouldn't change. So most of it should stay the same. But at the beginning of any project, you need someone who understands the local context, who understands that community to frame the importance of this project and to explain that context. And then at the end of the project, once the analysis is done and you have your results, you need someone to interpret those results with their understanding of what it means to that community and come up with conclusions and next steps, right? So you could hand off this job to AI and hope it does a good job, assuming it has all the information it needs, but it probably doesn't have the information that that person who understands the community, it probably doesn't have all the nuance and understanding that that person has to be able to really make these determinations. So sure, you could pass on certain things to AI, but you wouldn't want to. So these are the three main areas where I see, now that we've automated so much of this process, where do people put their attention now, right? The first is making sure the data is really good. We've done a lot of VAs, and no matter how much quality assurance our clients tell us they've done, we always find a lot of issues. So there's definitely a lot more time that can be spent looking at the data and making sure that hospital is in the right place. Because if it isn't, you're not going to do a good job of quantifying the flood risk. The second area is just giving that personal human touch, right? You need to engage stakeholders, you need to engage the public, you need to hear them out, take what they have to say into consideration. And it's not something we really want to hand off to a chatbot, right? You're not going to send a chatbot to your public presentation. You need a person there. So there's going to be a lot more of this, I think, a lot more opportunity now to engage with the public and engage with stakeholders and really do that entire process more so. And then finally, it's really the super important part of driving solutions. It takes champions to make things happen. So AI is not going to go out there and elevate your house for you. It's going to take a person or a group of people a lot of hard work for these projects to move forward. So we can get rid of the tedious part. You don't have to format tables anymore. Now you can spend more time making sure the data is good, talking to people, and making things happen. So that kind of wraps up my chat on AI. I'm happy take to chat about that more in the questions if there's more some part that you found interesting. But now I just wanted to quickly share our vision for what we are building. So some of you might already be familiar with Arcly. It is the platform that we aim to make global so that flood risk data is available to anyone and they can make decisions based on that data. So Arcly it's free to use. It's publicly available. It's currently available in Florida and Puerto Rico. And what it does is it makes that flood risk data in dollars accessible to anyone and also shows you what different solutions cost. So you can compare your flood risk to the cost of insurance and to the cost of flood mitigation solutions. And the goal there is to help as many people around the world make proactive decisions about how they manage their risk. So as we think about how do we scale this beyond Florida, scaling inside the US is easy. There's a lot of data. We could push the button and just keep going. But if we want to go outside the US, it'll get more interesting because we don't have all of these data sets. And again, going back to the SURF case study, that's a place where AI could come in and help to fill these gaps. So we already know that it's doable. And we got a great start working in Puerto Rico, where we were contracted by the Puerto Rico Science Trust to launch Arcly for the whole island. And in doing so, we came across some issues with the data. If anyone's worked in Puerto Rico, you know that the address data is a total mess. Like Uber only works in San Juan because the addresses are just, you know, my house is to the left of the tree at the top of the hill kind of address. So it took some work to make that experience intuitive and work for the users, but we eventually figured it out. So there's a lot of obstacles, a lot of data sets, but one by one, we plan to make Arcly a global tool. So that's all I got. I'm happy to do demos if there's time and take your questions now.
Yeah, I would love to see to have you do like a quick demo. Maybe I see maybe we have a couple questions. I see
Do
Brian
we
has
need to put our questions
oh
in the chat?
yeah.
Okay.
Yeah, go ahead. We can take a couple questions and then yeah, I think we would love to see a demo.
Okay. Yeah, let's
Yeah.
do questions first.
Do we need to put our questions in the chat? I'm sorry.
And you could just ask them. You can put them in the chat. You
Okay.
can ask them.
A quick question, Adrian. I think just thinking about the whole idea of AI, and when you're talking about like just the local solutions, right? Like the people that are closest to the problem, um, have a lot of the solutions. I believe that they just don't have the resources. And they also know things that maybe, AI doesn't know. So I guess my question would be is how do you assure that you find ways to keep that balance and then have and what kind of work do you do to kind of get buy-in? You know, I think with local governments it may be easier, but I think with like communities kind of buying into this whole idea of like, AI and this technology, kind of
Yeah,
being the answer to a certain sense without people, you look at movies and you see that like the robots have taken over and
yeah,
all this all this other stuff. It's a little bit scary. It makes me nervous to be honest, but yeah. I'm
yeah,
just curious how y'all have thought about that on levels of engagement with, governments and also with communities.
yeah. I guess before I get into how we address it with those folks, just like I think there's a lot of misconceptions about what AI is. Like my CTO, who actually understands AI very well, like rolls his eyes when people use that term because a lot of it is just marketing, right? A lot of it is people, there's a lot of things that are they really AI? Not really, but they get branded that way because it's exciting. So I think there's definitely a lot of hype, and people think of AI as kind of what is considered artificial general intelligence, like some being that can do all these things for you when really right now we're just getting lots of little pieces of it, right? So we have a model here that has a bunch of data that is really good at understanding text and answering things back at you, and then another model here that is really good, but there's no such thing as an AI that can do it all. So it's it's still people driven, right? It's still mostly primarily serving the purpose of getting better efficiency. It can also do a good job of automating simple tasks, but it's not that the AI is going out and making decisions on behalf of people for your community. That is not the case, right? That's a decision for us, right? For all of us. Do we want to, how much responsibility do we hand over to the machine, right? So driverless cars are a great example, right? You still need to be attentive, making sure that it's working after knowing that it drives better than a human because there's, sometimes you've got to make decisions, right? So we're not handing over the decision making to these tools. We are using it to help us. It's like I said with the flavor text, right? The part of the report that is totally standardized, that shouldn't change, the methodology shouldn't change the second time you do it unless you improve the methodology, right? So the part of the report that is standard and shouldn't change, that can be automated. The part where you need human context and human understanding, you could, but do you really want to? Like, no, you don't. So that's that's the thing. Like I would think of it right now, this might be extremely different a year from now with how quickly things are evolving. But right now I would think of it as like lots of little pieces where it can automate things for you, it can make things faster for you, but it is not doing your job entirely for you, right? It's for me, it's like let's use it to take the pain away. And now back to your question on like how we talk about it with communities. We don't really present ourselves as an AI company, honestly. Like we've automated vulnerability assessments. People like that. They want to make sure that they're compliant, and they are. But we don't really put forward the AI piece that much because to me, that's not what makes our company valuable. To me, it is simply a tool that makes us more efficient.
Thank you.
Yeah, absolutely. And I see another question I can answer. Oh, there's a few questions here. Um, when would you anticipate adding other states to the Arcly database? So we plan to eventually go national to the whole US. I think in the next year or two, we would like to do that. We're still figuring out what our expansion model looks like. But yeah, so in the next year or two, I would hope. Lindsay's question, what do you think about the impact of the use of AI on global warming due to the large energy needs for the computing? I don't like that. Like it's terrible timing. Like we've got a big problem with global warming, and now we're gonna throw this into the mix. It's very poor timing. I I don't like it, Lindsay. Probably probably feel the same way. Um, shall I do a demo and then go back to the questions?
Yeah, let's do a demo.
Okay.
Um,
So the idea with Arcly is that it is very user friendly. When we design it, we think about our moms. Like, can my mom use this? So you type in your address, just like you would on a platform like Zillow, and it takes you to your home. I'll talk about the map first. So we've got two data layers on here. We've got the FEMA flood zone, the regulatory flood zone, and we've got the results of our own analysis, the surf analysis at the property level, where the redder it is, the riskier it is. And we've got this fun feature where you can travel through time and see what the future looks like, called the time machine. And then we've got property level information. So this is my grandfather's home on the St. Lucie River in Palm City. His flood risk is $12,000 a year. So this is the big number. What does that mean? $12,000 a year of flood risk means he would have to set aside $12,000 every year in a piggy bank and do that every single year to then be able to keep up with his long-term losses. You can think of it as a self-insurance estimate. You can also think of it as like the hidden cost of flooding or the hidden ownership cost of flooding. Got some other basic information like the flood zone, your ground elevation, your BFE. And then we help you compare this $12,000 number, the scary number, to the solutions. What can you do about it? So flood insurance, 90 something percent of the time, flood insurance is the right answer for most Floridians. So we partnered with this flood insurance agency so that you can go in here, get quotes in 5 minutes, and go ahead and get a policy. So I'll just go through this really quick. What kind of home do you have? These are the questions that the insurance carriers are asking. What kind of foundation is it on? A slab, one step to the door, concrete, one story, and then some contact information. Once you go past this point, you can see your quotes, and then they might reach out. Okay, so the NFIP came back at 4,200, and our partners came back with 1,200. And I can tell you now that my mom used this to buy my grandpa flood insurance, and it cost 1,600 when he finally got a policy. So he did pretty well. And I'm glad he's finally got insurance. The only reason he got it wasn't because his grandson is a flood risk expert. It's because the state of Florida forced him to with the new law. So I thought that was kind of pretty funny. And then finally, the other thing you can do as a homeowner is you can elevate your house. The estimate to do this is if you were theoretically able to get a 30-year loan to elevate your house, it would be $16,000 as the annualized cost. So if you're comparing your three options, your flood risk is 12,000, insurance was 1,600, elevating was 16,000. The most logical short-term solution is to buy flood insurance. If you then think about the future, well, 2040, the risk isn't that much higher. 2050, it's okay, but there's this jump by 2060. The risk is a lot higher now, $28,000. That means the insurance will also be more expensive. So then elevating your home starts to become a more appealing solution at that point. And we're in the process of integrating some lower cost flood mitigation solutions. Like there's these barriers that you can put in your entryways that can give you up to 2.5 feet of flood risk reduction. So we'll be integrating some of these other kind of DIY floodproofing solutions as we move forward. But that's a little bit about Arcly. We can zoom out and see we've got the entire state. You can go in anywhere and see your building. And if you pan over on the map, you'll be able to see Puerto Rico on here as well. And that is it.
Yeah, I would definitely encourage everyone to go check it out. After Adrian and I did our tech check in preparation for this meeting, I like went right on and like put my house in, and it was super interesting. So I think that answers. Tasha, you had a question about Arcly having solutions with cost information. I think that that demo should answer that question. But did you have a like a follow up question?
No, that's it. Thank you.
Okay, perfect. And it looks like we've got a couple more questions popping up in the chat. Also, feel free to unmute yourself if you would, if you'd like to ask any more questions. But we've got from Brian Byfield. Does this have a built-in inflation factor?
That's a great point. This is all in today's dollars, right? So this is all
Okay.
helping you in today's dollars. It could be
Okay.
added easily, but it doesn't as it is.
Mhm. Awesome. Thank you. And from Kamiko Link, is there a video tutorial or demo?
That's the same question that Julia from my marketing team is asking me all the time. So we definitely
Uh-huh.
need one of those. Yeah. There's a tutorial. So if you go into Arcly, it'll ask you if you want a step by step. So we have that. I definitely need to make that video
Okay. Awesome. And let's see.
though.
Anyone else have any questions that they want to either pop in the chat or you can unmute yourself and ask your question?
Yeah, I had another quick question.
Yeah.
Um, and I don't know if you'd be able to answer this, Adrian, or not, but like, do you know any um, data connected to like how much the tool itself impacts like the usage of water connected to data centers and things like that?
You mean like AI computation and water?
Yeah, yeah, yeah.
Oh, I mean, so Arcly is not like actively using any AI tools. Arcly is
Oh, okay.
it's a data platform. It's just free access to data. It has some, dynamic functionality, but we haven't integrated any of this like ChatGPT type stuff into it or anything like that. Um, we
Okay.
We've considered the idea of having like a chatbot so that if you're confused and you don't understand what the flood risk means, you can ask it questions and it can explain it to you, kind of like I did on the call just now with the demo.
Hmm.
That's where there would be value to it, just helping people with their decision making process, because there's a lot of steps to take into consideration. If you own a property, if you plan to own it for 2 or 3 years, flood insurance makes sense. If you plan to own it for 100 years and have your kids inherit it, it's like grandma's home on the beach, then okay, you're going to have to do mitigation. So depending on your situation and your risk tolerance and the data itself and your solutions that are available to you, it could help walk, a little AI agent chatbot could help walk you through that. Potentially, we've thought about that, but we haven't implemented that yet. So
Okay.
as far as how much water and energy AI uses, I'm sure there's data on that.
Yeah, yeah. No, I was just wondering if this was like a process that adds to it, but you answered that question.
Good.
Yeah, and I think that Adrian, you touched on how I think there is a lot of like misconceptions around what is AI and what isn't AI. I know, like I have a lot of like I had a lot of questions coming into this presentation, and I think like there's a lot of things that I always assumed were AI that actually aren't. So that's been really interesting to like learn a little bit more about what is AI and what isn't, and how. Go ahead.
I was gonna say, like I said earlier, like my CTO who really understands this stuff used to roll his eyes every single time someone mentioned AI. Like it was like, okay, Noah. But now he rolls his eyes less because this stuff has evolved pretty quickly in the past couple of years, So he used to really make fun of it and said, "Oh, that isn't AI. Come on, dude." Now he's
Mhm.
like, like it's not AGI. So,
Uh-huh.
you know, it is pretty mind blowing what it can do. Um, but it's yeah, there's certain places where it's going to be really disruptive for people for sure. Um, but I think for a lot of folks, it's going to make the tedious parts of their job go away. At least that's what I'm hoping.
Mhm.
That hope for the positive, and hopefully it's not a Terminator type scenario like Jazz was alluding
Right. Yeah. What I'm like
Don't do
getting
that. Yeah,
a
don't
little
put
bit.
that on me.
to.
Yeah.
Yeah, what I'm getting is that it can be a great tool to increase capacity, um, right? But it's not going to replace most jobs,
Right.
but it can make your job more efficient. Any other questions? I think I see there's some competition in the chat about where Arkley is going next.
I
See
love
between
that.
North
Yeah.
Carolina and Georgia. Um, Brian, I see had a Brian dropped his contact information into the chat and is interested in connecting, and a few questions around compound flood modeling.
Mhm.
Um, can you speak at all to how does Arkley address compound flood modeling, incorporate that into its model?
Yeah, I mean, Arcly is flexible to whatever flood models you have, right? So we're updating it every 3 or so months with new data. So if we get new exposure data, new buildings, we'll put them in. If someone comes along and says, "Hey, we have an incredible compound flood model for the entire state of Florida," we'll jump on it. We'll want to learn about that model. So it's flexible to any input. We have our own internal coastal model, and then inland, we'll do a mix of leveraging the models that our clients have for their communities and regions. And if we don't have any inland flood model, then we'll use FEMA's data as a baseline, right? So the idea is to continuously update it with the best available data on the flooding side, on the whole surf thing that I talked about.
Mm-hmm.
It's a constant process. Yeah.
Okay, awesome. And that kind of leads into another question in the chat about which data sets you're pulling from to inform the flood models. Is it just latest available? Where exactly are you pulling the data sets from?
Yeah, I mean, sometimes, God, there's a lot of good questions here.
Yeah.
So in Florida, we look for the best available DEM for the state of Florida, which gets updated every year or two. And since we're doing the vulnerability assessments, we're kind of aware of the data sets that are out there as well. On the exposure data, there's a big data pipeline that we have to get, okay, we have polygons from there and polygons from here. We have a way of putting them together, adding the tax assessor data. If there's elevation certificates, adding that. So just that entire data, orchestration coming together is a big task. And on our coastal flood model, we're using a combination of FEMA and NOAA data. Originally, we were using the NOAA 2022 extreme water level data. That didn't seem to work very well in Puerto Rico, so we kind of normalized it with some FEMA data. But yeah, let's see if there's anything else.
Yeah, there's a lot in here. Really, I think
I'm
it's
gonna put
really exciting work.
I'm gonna drop my email in the chat for everyone that has questions they want to follow up on.
Yeah,
Definitely want to chat with you, Brian. And I see that you've got competition in Georgia, so
yeah.
I like that.
Are you able to hear me clear?
Oh, yes, you can hear
No,
you.
Brian, we can't hear you at all.
Yeah. Quick question just around the human component of all of this. Um, how does how do you guys factor that in? I mean, vulnerability, we understand damage to buildings and so on and so forth, but in terms of human cost, what it takes for somebody to move away, that it just I have a million questions, but just broadly, how do you um, factor the human side of this, the impact from flooding and so on, is it model or is it not involved?
I
Very
think
clear.
so. It's hard to hear you, Brian, but I think you're asking how do we factor in the human component?
Yeah, correct.
And are you talking about the socioeconomic impact analysis that I talked about earlier?
Yeah.
Okay. Yeah, so I mean, all of the details are in the publication, so if you want to have some good bedtime reading, that's a good place to go. But but it's basically, as you're probably aware, so the census data is aggregated to protect people's privacy. So
Yeah.
we don't know, it's a lot easier to quantify the flood risk in dollars to a given building than to know who lives in that building and what their situation is, right? So, but we do know at a kind of a neighborhood scale some information about people's income and their demographics.
Yeah.
So the reason we developed SURF in the first place was because we wanted to answer this question of, okay, We have this aggregated census data. We have this property level risk data. How do we determine how many people could be impacted? And to do that, we had to set up this Monte Carlo simulation where we're basically sampling from the data from the census data and saying, okay, we know that 10% of the people in this neighborhood are in this income bracket. So we place them randomly in the homes. We do that for all the income brackets, and then we run the model. And then we do that thousands of times so that we get a whole distribution of all the potential outputs. And then we have like a mean and a standard deviation on the output, right? So we basically get a good range on how many people could be displaced. So this was, the alternative to this is that you have these like indices, like these indices that are basically ratios, right? Oh, it's a zero point 0.9 and a 0.8. But what does that really tell you? So we wanted to really quantify, hey, there's this many households at risk of being displaced. And we say that they're at risk of being displaced if their risk basically outpaces their income, right? So if their discretionary income is negative after you factor in their flood risk, then they could be displaced by flooding. And you can move that threshold up or down. But that's, in a nutshell, that's how we quantify that.
Excellent, excellent. I will definitely be reaching out to you ahead of Georgia.
Sounds great. Yeah, it's a race.
You're too late, Brian.
All right. Well, it is 10:55, so that is all the time we have for questions. But I will be downloading the chat box and sending it to Adrian. Adrian, if you're willing, you can drop your email address into the chat for folks to follow up with you. I see. Yeah, I see. Oh, you already did. Thank you very much. Yeah, I see a couple of people who have some more questions. Maybe looks like a couple of people who maybe are interested in having you speak at some conferences or other webinars. Um, so thank you so much. This was obviously very engaging and really, really interesting topic. And again, I encourage everyone, if you haven't, after this, go check out Arcly. Um, it was so interesting to like see where my house was and to like look at the projections for the next. I mean, it goes up to what, like 100 years from now or so.
End of the century, yeah.
Yeah.
Sea level rise. Yeah, exactly. For now, it's sea level rise, but as rainfall changes and storm surge changes, it'd be cool to factor all this in. So, thank you so
Right.
much, Claire. Thank you so much, everybody, for your time today.
Yes. Thank you so much, Adrian. And now we have a couple of minutes left for partner sharing. So if you have any updates, announcements, calls for input, please feel free to drop them into the chat, or you can unmute yourself and share as well. All right, and not seeing any announcements, but again, if you have anything, feel free to drop it into the chat and I will include it. Oh, I hear.
This is Brian. This is Brian. Hopefully, you guys can hear me a little better. Just quick announcement from state of North Carolina. The resiliency team has now officially moved to the North Carolina Department of Environmental Policy. So we are now known as the State Resilience Office in NCDEQ. And most of you, if you email me, you'll see a new email address. And we'll reach out a little later to share what's different now. But just to say that we've officially moved and we have a new home, and this is our new permanent home.
Thanks, Brian. Your audio is a little tricky to hear, but I believe you're sharing about the transition to um, your now department is now the State Resilience Office, and to stay tuned for more announcements around that. But if you have any, you can also drop it into the chat because, like I said, your audio is a little bit tricky to hear. All right. Well, with that, Again, thank you everyone very much for joining. Thank you so much, Adrian. Feel free to stick on and drop announcements into the chat. I'll put them into our newsletter. But other than that, thank you all and enjoy the rest of your day. Thanks for joining us today.